Hello, ladies and gentlemen. Welcome back to Precalculus. We're in Chapter 1, Section 2, the second half of that section. I'm talking more about inequalities. Okay, so let's dive right in and talk about compound inequalities that involve more than one solution interval. Okay, more than one set of answers. Okay, the intersection of two sets A and B, written as A intersect B, is the set of all elements common to both sets. So what elements are in both sets of intervals? Okay, the intersection of two sets is described using the word and. Okay, think of it as an and. Okay, the union of two sets A and B, written as A union B, it's a typo here, folks. A UB is the set of all elements that are in either set. So if an answer is in one set or the other. So the union of two sets is described using the word or. Okay, and note the typo there. It's A union B. Okay, can satisfy either inequality. Okay, so if we're looking right here, we have a set A and a set B. And we want to know what is the intersection of A and B. So what elements are in both? Well, in both of them, we can see that we have a 1 and a 2. So the element 1 and the element 2. Okay, the number 1 and the number 2 is in both set A and set B. Okay, again, we have another typo over here. This is supposed to be A union B. This is also supposed to be A union B. Okay, so we're looking for what elements are in either set. Well, -2 is in A, -1 is in A, 0 is in A, 1 is in A, 2 is in A, and also 3 is in B. So we only care if they're in either or. Okay, so here we go. We're going to graph the following. So we're looking for inequalities here where x is greater than or equal to -1 and less than 3. So -1 is about right there on a number line. 3 is about right there. Okay, sometimes we use solid dots for equal to and open dots for not equal to. Okay, so we're looking for greater than or equal to -1 and less than 3. So we're going to be shading in between. And we're looking for the intersection of both intervals. Numbers greater than or equal to -1 go on forever to the right, and less than 3 go on forever to the left. But we're looking for the intersection, which is right there, which we can write using interval notation. -1 with a bracket, 3 with a parenthesis. Okay, now here we go. We have an or statement. So we want less than -1. So we're going to go with an open dot, shade to the left, or greater than or equal to 6. So we're going to shade to the right. So if we do interval notation, we could say -infinity to -1 with a parenthesis, union, bracket 6 to infinity. Okay, now this is just some mini solves here. So we subtract 5, so we get -4, and we divide by 4, so we get x is greater than or equal to -1. And if we just add our x over to the other side, subtract the 1, we're going to end up with x is less than 2. So we're looking at an and statement, going to be an intersection. So here's -1, here's 2. We are greater than or equal to -1, and we are less than 2 and shading in between. Okay, so in interval notation, -1 to 2, not inclusive. Okay, as seen here in example 4, there's our answer, but it can be written like this. X is greater than or equal to -1 and also less than 2. This right there is called a joint or compound inequality. Okay, so here we have an example. Okay, now solving these at the bottom here is no different than how you've always solved them. Okay, so we want to get that -2 out of the denominator, so we're going to multiply everything by -2, the left and the right. So this is going to become -4 here and 8 here. But remember, when you multiply or divide by a negative number, you got to flip your inequalities. Our middle is now 3x plus 2. And we can subtract 2, so we got -6 over here, less than 3x, less than or equal to 6. and divide by 3. So we end up with -2 less than x less than or equal to 2. A compound inequality there, so we can draw -2. We can draw a 2. You can even do it, instead of using an open dot, I can use a parenthesis sometimes. And instead of using a closed dot, I can use a bracket. To show you a different way here, it's a great time to do another way for an example. Shade in between, and it's real easy to see now how to do your interval notation there as well. Okay, looking at the back, we're actually going to have you guys do all 6 of these examples on your own, but I do want to walk you through a couple pointers. Notice in the first couple here, they're making you play with negatives. Okay, a lot of negatives floating around. You can see the or, you can see the and, so you know if it's going to be a union or an intersection. But when you're playing with negatives, remember that if you divide or multiply each side by a negative, you got to flip your inequality. Okay, and then quick pointers down here, down to example 5 and example 6, etc., especially example 5. These fractions tend to mess with people's head. Just remember that you can multiply by the least common denominator here, which is 6. So if you multiply everything by 6, -2/3 times 6 is -4. 1/2 times 6 is 3. And 1/6 times 6 is 1. Okay, and lastly, don't forget to distribute your negative sign as you're multiplying through here and solving for x. So solve these 6 and bring them to class fully completed, and we'll go over them. Okay, here we are on the back, and we're going to talk a little bit about domain. Okay, so domain, if you remember from Algebra 2, is the set of allowable values in an expression. So what are you allowed to input for x, essentially, is the basic way of saying it. Okay, so the default domain is the set of all real numbers. So we always just assume we start with we're allowed to put in every real number, and then we consider which ones we have to take out. Okay, so anything that makes the denominator 0, bad news. Okay, you can never divide by 0. Anything that creates a negative under a radical, and specifically it has to be an even radical. Okay, so we can make a special note underneath an even radical, and then later we'll look at the allowable values in chapter 3 and 4 of what we're allowed to put into a logarithm. But let's do some examples here real quick. So here we go. We have an even radical, square root of x plus 3. So we know that we're never allowed to have anything negative underneath a radical. So we can say that, well, if nothing's allowed to be negative under there, then x plus 3 must be greater than or equal to 0. That has to be a true statement. Therefore, x has to be greater than or equal to -3, which we can draw on a number line. There's -3, greater than or equal to, and we're going to shade to the right. And we can write it in interval notation as -3 to infinity. Okay, that's the domain of this function. Now looking at example 8 here, 6 divided by x minus 2, we don't really care about the numerator. The numerator can be whatever. Okay, but we care about anything that makes the denominator 0. Remember, the denominator is not allowed to be 0. Okay, so similar to the first example here, example 7, where we could make up our own little expression, x plus 3 is greater than or equal to 0. Over here, since the bottom's not allowed to be 0, we can say that with an expression. X minus 2 is not allowed to equal 0. And you can treat that not equal to the same way you treat an equal to. So x is not equal to 2. So we know that every single value on our number line is good to go except for 2. So we can shade all of those values to the right, all those values to the left. All of those answers are allowed in our expression here except for 2, because 2 makes the denominator 0. So we can write that as -infinity to 2 union with 2 to infinity. Okay, notice this is a clever way of how we say don't include the number 2. Okay, now we can look at this a variety of ways. I'm just going to factor it. I'm going to say this is the difference of squares, factors into binomial conjugates. X plus 3, x minus 3 is the same expression. And we know the denominator cannot be 0. So x plus 3 cannot equal 0, and x minus 3 cannot equal 0. Okay? Just because 0, if one of these was 0, 0 times anything is going to be 0. So we know that x cannot equal -3, and we know that x cannot equal 3. So there's negative 3. We're not allowed to equal that. There's 3. We're not allowed to equal that. But every other answer on the number line is a quality answer, is allowable, is in the domain. Okay, so now we can write that using interval notation, saying just read left to right. So negative infinity to negative 3, non-inclusive. Union with negative 3 to 3, non-inclusive. That's just that little middle section right there. And then lastly, union with 3 to infinity. Okay, that's a little bit about domains. Now let's take a look at some word problems here using inequalities to compute a desired test score. Okay, maybe something you guys have done before to figure out what you want to get your final quarter grade to. So anyways, here we go. Let's say Jim earned a score, or earned his previous scores of 78, 72, 80, and 86. Okay, on his first 4 tests. He wants to know what he has to get on his 5th test to have an average of 80. Okay, so if we recall how to average, you add up everything, right? So we have this, 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 this. If we add up those 4, we'll get 316. Now remember, he's got to take one more test. We don't know what that score is, and he wants to know what to solve it for, so we're going to call it x. So all 4 scores plus x divided by 5 will give us our average, or Jim's average, I should say. Okay, now we want that to be at least an 80. So we want it to be less than or equal to, or I'm sorry, greater than or equal to, put it backwards, greater than or equal to 80. Okay, so we do some quick solving here and we just multiply by 5 and we say, okay, 316 plus x has to be greater than or equal to 400. And then we subtract the 316 over, so we get our final answer that Jim must score an 84 or higher in order for his average to be an 80. Okay, let's take a look here at this last example here. So as Sarah is moving out of her new home, she must decide which moving company to hire. Okay, so Movers Rentals charges $15.75 per day. Okay, flat rate of $15.75 per day plus an additional 35 cents per mile. Okay, We Move You charges $25 per day plus an additional 30 cents per mile. Okay, so you can see right now, like the first company is going to be cheaper if she doesn't drive any miles at all, because the per day is lower than the other one. But the question they're asking is how many miles must she drive in order to make this second one, this We Move You, a better option. Okay, so Movers Rental and We Move You. I'm just going to kind of make a little reference here. Okay, so Movers Rental, let's go back and review, charges $15.75 per day plus 0.35x, for x being the number of miles. Okay, and We Move You charges $25 per day, but 30 cents per mile, or 0.3x. Okay, so we're saying how many miles x must be driven in order for this one on the bottom, We Move You, to cost less, because clearly it's going to cost less eventually because it's cheaper per mile. Okay, but not right away because this one is cheaper per day. So we want to know, when is 25 plus 0.3x going to be less than 1575 plus, that's a plus sign, 0.35x. Okay, so just some quick simple solving here. I'm just going to subtract my 0.3x over from the other side, so I'm going to end up with 0.05x, 0.35 minus 0.3. And then I'm going to subtract my 15.75 over to the left side, and I'm going to get 9.25. And if we divide everything by 0.05, okay, we're going to see that we get X must be greater than 185 miles. So as soon as she drives even one more mile more than 185, not 185 exactly, but one more mile, so 186 miles, we move you is going to become a cheaper option. Okay, if she's moving any less than 185, then she wants to go with movers rental. Thanks a lot, guys. Let me know if you have any questions in class. Look forward to seeing you.